Okay, so in this video we're going to do interpreting computer regression output, which should not be too complicated. The last one is, though, and I'm going to try to go slow into both of those because the last part is just, I'm just confused half the time. So a number of statistical software packages produce similar regression outputs. So be sure you can locate the slope, the y-intercept of A, the values of S and R. So usually, if you're given something, you need to be able to at least identify what's going on. So the constant, your coefficient for the constant is going to be your y-intercept. Your miles driven for the coefficient is going to be 0.16. That's your slope. Okay, your standard deviation for the residuals. So your prediction error is going to be about 5,740, which seems like a lot to me. Your R squared is going to be 66.4%. So 66.4% of the variability could be accounted for between the miles driven. I guess this is, are we still talking about the Ford F-150 in this one? Because I feel like we are. Can be accounted between the miles driven and... what was the other one? What were we doing? We were doing miles driven versus cost, right? Yeah, miles driven versus cost. Okay, so we have, here's your computer output. Okay, don't worry about the R squared adjusted. That's not what we were concerned about. The T column and the P column, we're going to learn what those two means towards the second half of this year. No, we're not really going to do anything with those right now. Okay. All right. So interpreting, it gives you a random sample of 15 high school students. Were selected from U.S. Census. Each student has a sample below. Least squares regression was performed. A scatter plot with a regression line, and here's a residual plot, which means, yay, we can actually use a line to model our data because we do not have a pattern in the residual plot. And some computer output from a regression are shown. So the important ones that we really care about are our S, that's your standard deviation for the residuals, your R squared, which is not very good, but well, can't do much about it. Your coefficient, your constant, and your foot length for the coefficient of the foot length. Okay, so we're going to write this up really quickly in the next one because it asks you what's the equation of the least squares regression line that describes the relationship between the foot length and the height. Define any variables that you use. So what is X, what is Y? That's what it really wants to know. Interpret the slope, which is what we did today, and then we're going to do it again. Find the correlation, which is kind of easy to do. Is the line appropriate model to use for the data? Explain how you know. Okay. Oh, that line should be easy. I actually just answered it already. Look, you don't have a pattern, so yes, a linear model is appropriate. Okay, so your equation is going to come from your coefficients, constant, and your foot length. So you should get, for part A, y hat equals, let's see, 1.103.41 plus, we're in the positives, right? Plus 2.7469x. Okay, so I didn't actually define any variables in this, which is what I'm going to do right now. So our x is going to be the foot length, and our y hat is going to be the predicted height. In centimeters, and foot length in centimeters. Sorry, that's a C. And our predicted height in centimeters. Okay. All right, part B. We have interpret the slope of the regression line in the context. So our slope is 2.7469. Okay, so 2.7469 over 1. So 1 is going to be our height. The 1 is the y, so this is going to be our height. And this is going to be our foot length. So for every 1 centimeter, okay, so we have for every for every 1 centimeter in height, we have a growth, well, for every 1 centimeter in height, I don't know what to say with that one. We have 2.74 feet. The foot length for every 1 centimeter in height corresponds to 2.74 centimeters in foot length. I guess that's okay. Shouldn't be too complicated. That should be okay. Let me see what the book says, just in case. Okay, so for every centimeters of foot length, we have an increase of 2.7469 centimeters in height. Okay, that works out. So every 1 centimeter in height, there is an increase of 2.7469 centimeters in foot length. Okay, I'm fine with that. That's okay. So for every 1 centimeter's height, there is an increase. There's an increase. That's 2.7469 centimeters in foot length. Okay, that works out. Part C, find the correlation. Haha, okay. All right, this is the math stuff that I was talking about. Okay, so part C, find the correlation. Now, you're looking for something here that says R, and there isn't anything that says R. You only have R squared equals 0.486. Okay, well, remember, R squared comes directly from R. If you take R and you square it, you get R squared. So just work backwards and take the square root of both sides. So R is going to be whatever the square root of 0.486 is, which is going to end up being, I don't know, I can't do that in my head, 0.486. 0.69. 0.6, well, we can say 0.697. So roughly around 0.7. Okay. Now, if you look at it, okay, that actually makes a lot of sense because it's not a very strong association going on over here. So 0.7 makes a lot of sense from the association of that scatter plot. And then the last part is part D. How do you know a linear model is appropriate? Well, you can tell there's no overall pattern in the residuals. So yes, a linear model would be appropriate for the scatter plot. And you can write that down over here. Okay, that was this one over here. I was just writing all the answers on the previous one. The next thing is about regression to the mean, and this is just weird to me. So you're going to use this when you have very little information, and you'll see why in the next slide. So using technology is often the most convenient way to find the equation of a least squares regression line. It's also possible to calculate the equation of the least squares regression line using only the means and the standard deviations of the two variables and their correlation. So if you know the mean and the standard deviation from the explanatory responses, and then if you know the mean and the standard deviation, the regular standard deviation from the response variable, and then find their correlation, you can do that on the calculator, you should technically be able to find the equation of the line. This is kind of like, how do you find the equation of a line from 2 points? Given 2 points and a slope, it's kind of the same thing. So what they do is they put it into two concepts that you should be able to at least handle. So they take the explanatory variable x and the response variable y for the n variables. You calculate the means and the standard deviations of the two variables separately, find their correlation r, and then you get the b value if you take the r value and then multiply it by the standard deviation of y divided by the standard deviation of x, and you get the a value if you take the mean from the y's and then subtract it by the b, the value that you got, times the mean from the x's. Okay, and we're going to do that in the next one. So this is the two that you would want to use if you only knew the means and the standard deviations from the two variables and their correlation. You need to find their correlation. So we're going to do that in this problem over here. Okay, so I'm going to write everything out that we know, because this should go a little bit better if we do this. Okay, so we have the mean for y, and we have the standard deviation for y. Those are two that you need. You need the mean for x, and you need the standard deviation for x. Okay, and lastly, you need the correlation for both. So you need 5 pieces of data for this to work out. And luckily, it gives us most of that in the problem. So in the previous example, we used data for random samples, 15 high school students. The mean and standard deviation of the foot lengths, which are x's, are going to be 24.76. And S of x is going to be, the standard deviation just for foot length is 2.71 centimeters. The mean for the heights is 171.43, and the standard deviation for the heights is going to be 10.69. Okay, and the correlation between the foot length and the height is going to be r equals to 0.697, which is actually what we found, by the way, in case you didn't realize that. We actually did it over here, right? Okay, so we should get, ideally, right, if the problems match up, and they do match up, we should get the same equation that we got in part A when we set it up from the coefficients for the constant and the foot length. We should get the same equation because it's the same data. Okay, we're just kind of working the other way around. Okay, here we go. I did not memorize this, so I'm going to have to look at it. So B is R times SY over SX. So B, whatever we get value for B, is going to be the R times SY over SX, standard deviation. So the value of B is going to be 0.697 multiplied by 10.69 over 2.71. So 10.69 over 2.71. So we're going to get a B value of 0.679. I'm just working it out. 0.679 multiplied by 10.69 divided by 2.71 and 2.678. All right, so I'm going to check because I can't remember what we just got. Okay, I guess we're off a little bit. Why are we off so much? It's kind of on a lot. Did I type that in correctly? Oh, I totally just transposed those numbers. Duh. No, go back. There you go. We were supposed to be, this is supposed to be 97. Ah. We're supposed to get the same thing. Yay! And that's it, right? Yay! Okay, good. So 2.749. Okay, that makes more sense. We're not supposed to be off that much. Maybe off by like 0.001 or something. Okay. Sorry, I accidentally transposed the numbers. Okay, that's B. And then your value for A is going to be y bar minus B times x bar. So value for A is going to be y bar minus B times x bar. So value for A is going to be y bar 1.171.43 minus B 2.749 times x bar of 24.76. And we were supposed to get 171.43 minus 2.749 times 24.76. And we get 103.365, which is hopefully close to what they got. 103.41. Why are we off? Oh, we rounded. That's right. We probably, if we'd have kept to 4 decimal places, I bet you would have come out the same. Okay, so your y hat is going to equal 103 point, I don't know, we can say 103.4. I'm just going to round to the tens place. Plus 2.749 x. There's your line. and it should match the previous one. Yay, it does. Okay. All right. That's it for this video. Hopefully it wasn't too much. You can go back and re-read it. I mean, re-listen to it if you need to.